All right, so section 2.6 is going to combine a couple of things that we've been doing into a single section. So one of the things that we've done most recently, of course, you just did the quiz on and so forth, was factoring. So we're going to see some of that present in this section. The good news in terms of factoring once we get further on than just learning how to do it is the factoring tends to be more of the easier types of questions than the more difficult types of questions. So that part's kind of nice. Not always, but more of that is what's present. The other thing that we're going to see present in what we've done, what we're doing today, is what we did back in like the first unit when we were looking at fractions specifically. So to start with, I want you to remember what the domain is. The domain is a set of all input values allowed for an expression, or it could be an equation. In particular, when we're working with denominators, we want to remember that the denominator can't be 0. So our domain issues, when we have them, are going to come from locations where the value would make the denominator 0. Another thing that I'd want you to take a look at or to recall, I guess I don't have it written as a separate slide, but I'll write it in here, is to recall a fact from fractions that if you have c times x and c times n, this is the same as just having x over n. And what we did when we did this is we looked at something and we called it like reducing or simplifying, things like that for fractions. And we did it in such a way that we said, does the numerator and the denominator both divide by something? And if they do, then we simplify or we reduce the form of that fraction. So this fact is very important for what we're about to do. This fact is what allows us to look at things like, let me skip this one for a moment. Oh, I skipped over example 1. I'll come back to it anyway. There's my recall. No wonder. But this fact is what allows us to do things like on number 2 and number 3, canceling things out, right? So clearly when you look at the 8 and the 48, you're like, oh, look, they're both even, and we can reduce and so forth. All right, so let me go back and pick up the question I missed. I'm so sorry. Excluded values. Okay, so taking a look at this particular fraction, I mentioned denominators not being able to equal 0. Sometimes you can just look at the denominator, you can say, oh, look, yeah, x can't equal 5. That would make the denominator 0. Sometimes they're messier, like this one, and you might not necessarily be able to just see it at a glance. If you can see it at a glance right now, that's fine. It's the number 4 that it can't be. But if you aren't sure what to do with the fraction's denominator and where it would equal 0, what you can do is you can actually take the denominator and write down does not equal 0 and solve it just like it were if it said equals 0. So we would move the 12 or the 3w, your choice. I'll move the 3w to the other side. So you have 12 on the left and 3w on the right. Then what would you do? Yeah, you'd divide by 3. And what we would say then, of course, is that w cannot equal the number 4. Now, that's not exactly the domain, but it's the piece that's excluded from the domain, right? And that's how the question was asked here. Find excluded values. Well, the value that gets excluded is x, or w in this case, w. It can't be 4, because if w were to equal 4, the denominator would be 0, and we cannot divide by 0. You might be asking, well, why can't we divide by 0? And I'd like to show you that real quick, because every now and then people are thinking, well, why can't I? Or you just know it as a fact, but you just don't know why that's true. So let me give you an example of why this is true. Let's say, for instance, that you could divide by 0. It's totally legit, no problem. Well, it would have to equal something. Let's just call it c. Okay? Well, what that means, hang on. What it would mean if I could actually divide this by 0 is that I would be able to multiply by the 0 on both sides, thereby canceling this division of 0. And I would have to be able to have some value for c so that when I multiplied it by 0, I could get to 4. That's the definition of division. I can't do that. There's no c value that does that. But other values do. For example, why is 4 divided by 2 equal to 2? Well, the reason is because if I were to multiply by the 2, these 2's would cancel, and I do in fact get the 4 on the other side. There is a value when multiplied by 2 that gets me 4. You can't do that with 0. So that's why we get excluded values when the denominator is 0. Okay, back to what I was thinking about where we were headed for the majority of our section, which is about simplifying fractions. We're taking a look at pieces, and the first couple, or the first one example anyway, where they're in factored form already. So we're going to look at the 8 and the 48. What do 8 and 48 both divide by? 8. And if you didn't recognize that it was 8 and you did it by 2, that would be okay. You just divide them by 2 and you'd say, oh wait, look, I can divide it by 2 again. Oh wait, look, I can divide it by 2 again. You'd notice that there's more. 8 is the biggest value you can divide by. So 8 divided by 8 is 1. What's 48 divided by 8? 6. Okay, is that good? That's what we've done before. There's nothing that's different about that piece. However, the next piece is taking a look at the factored pieces and recognizing that, look, see there's a 3u plus 8 on the top and a 3u plus 8 on the bottom? It's just like having an 8 on the top and the bottom. I can cancel them. That's because it's a factor. I can't do that with the u plus 3 or the u minus 5. I know they both have a u in them, but it's a u that's added or subtracted with something. Okay? The entire expression in the parentheses does not match the other entire expression in parentheses. So what that means is that on the top, I have technically 1 times u plus 3, but that's just u plus 3. On the bottom, I have the 6 that I got from when I divided, and I have the u minus 5. If you multiply the 6 through, that's okay, but it's not necessary. The reason is because in this form right here, we can look at it at a glance and know there's no more reducing that we can do. If I multiply it through by the u, it's harder to see that just by looking. So this version of it is perfectly fine, which is why the directions say to leave it in factored form, is because we have that more immediate being able to know I'm done than if we multiplied it back out. Okay? Now, that's all well and good. That one was already factored. Number 3 is not. Yeah? But we've learned how to factor things that are like number 3. What do you notice on the top when I consider 15u squared and negative 10u?
They have 5u squared in common.
They do. They have 5u in common. So if I take 15u squared and I divide by 5u, what am I left with? A 3 and a u, so 3u. And if I take negative 10u and I divide by 5u, what am I left with? A negative 2. Now, to be perfectly honest, my expectation is that one of these things that just came out of my factoring on the top is probably going to show up in the denominator, right? Of course. I mean, that's what I expect to have happen. So these are the things that I'm looking for showing up in the denominator. It's not just going to be all factored and I'm not going to be able to do anything. That would be sort of silly. Yeah?
Why do they just have 5u in common and not 5u squared?
The 10u doesn't have a u squared in it.
Oh, so you gotta count those two and not just the 15 and 5?
The 5 on bottom has nothing to do with what we're doing yet. We're just doing the top.
Oh, we're doing the top.
We're only looking at the top. Yes. No, I didn't even think about the fact that the denominator had that going on at the moment. I was just looking at the top.
I got you.
Okay, everybody good with that? Okay, so now we're going to look just at the bottom. Just at the bottom, what do they have in common?
5.
A 5? Anything else? And a u. They have a 5u. So if I take the 5u squared on the bottom and I pull out a 5u, what am I left with? U. And if I take the 25u and I pull out a 5u, what am I left with?
5.
A 5. Okay, so considering this now in factored form, what can I reduce from the top and the bottom?
5u.
The 5u. These pieces in factored form match perfectly. The others don't. Again, I know there's a u on the top and the bottom. I see that as well, just like you do. But it's got addition and subtraction. So let me just show you with some numbers why we can't just decide, well, why don't I just cancel the u out? So take a look at this. What if you had 7 over 2? Actually, let's do 7 over 3. That'd be fine. 7 and 3 don't have anything in common, right? Well, of course not. But if I were to write this as 3 plus 4 over 3, would it be appropriate to cancel the 3's out? Well, it shouldn't be, because when we simplified it as 7 over 3, I couldn't reduce, so I shouldn't be able to reduce over here. And if I tried and did something like this, I'd end up with either, depending on your perspective, 1 plus 4 or 0 plus 4, and neither of those is equal to 7 over 3. So you can't cancel pieces out if there's addition and subtraction. You can only cancel it if the entire factoring matches. So on the one we just did, our answer ends up being 3u minus 2 over u minus 5. Is that okay? All right, let's take a look at number 4. Number 4 doesn't have common factors like the last one did on the top and the bottom. It just doesn't. In fact, number 4 on the bottom doesn't have anything. Y plus 4 has got nothing in common. But the numerator is one of the special factoring techniques that we encountered in the last section. What factoring technique can we use on the numerator? It's a difference of squares. So I have each piece squared, and it's a binomial, right? And it's subtraction in between. James, what will this factor into?
Y minus 4, y plus 4.
Mm-hmm. Is that all right? And then the denominator is still a y plus 4. And what do you notice?
Common factors.
Yeah, there's common factors. There's a y plus 4 in the numerator and the denominator. So I end up being left with simply y minus 4 on top. Technically, there's a 1 on bottom, but division by 1 leaves the numerator the same. This is simply y minus 4. Now, I'll guarantee you right now, if you jump from here to here, I'm not giving you any credit. That's not going to work. And I can tell you exactly why. On this one is a really good example to show you why. It's really easy to look at this and say, hey, look, I'm going to cancel the y and the y, and I'm going to cancel the 16 and the 4, and voila, I end up with y plus 4. Well, or y minus 4. You do, but you did it all wrong. And had the values been slightly different, it wouldn't have worked, right? I want to know that you're factoring to do the cancellation, because not in all cases will that actually work out for you that way. All right, number 5. All right, so number 5, we have more going on. We have a trinomial on top. And if you want to use AC method as you're doing that, you can. But because the coefficient at the beginning is a 1, trial and error works pretty well. So I'm going to default, when I have a coefficient of 1, to trial and error. So I have on the first one, or on the top part, 2 factors. And I'm supposed to be using y, so I have a y and a y that will give me y squared. So trial and error says I look at the back value. This is a negative 24, and I look at the sign. What does the negative at the sign at the back tell me to do? Different signs. One will be positive, and one will be negative. And like we talked about before, the order doesn't matter. Put them where you want to put them. 1 positive, 1 negative. I need numbers that multiply to 24. So kind of like when I did the AC method, let's write out some options. I mean, I can do 1 and 24. What else can I do? 6 and 4, 8 and 3, or 2 and 12. Right? I have 4 choices. We can pick one. I'm going to pick 6 and 4. Okay, so if we pick 6 and 4, I know I'm doing it wrong on purpose. If I pick 6 and 4 and I put them in like this, what's going to happen?
It's going
It's going to be a negative, yeah. So my sign will be wrong. This is a positive 4, and this is a negative 6, and I'd get negative 2. So that's no good. And again, if you want to use the AC method as you do all these, it's not a problem. You can do that. The signs that I picked are wrong. In particular, I can actually leave them and do that. If I did it in the order that I just did, and I recognized that I got the right value but the wrong signs, we talked about the fact that we can just change our signs. So I can make this y minus 4 and y plus 6. And if I check these now, the inside's negative 4. The outside's positive 6. And negative 4 and positive 6 is positive 2. The factoring's correct. Denominator. Well, it's binomial, and I don't have a lot of options, but I don't necessarily want to just jump right into difference of squares because this doesn't have each term squared. Does it? It doesn't. But what about the 2?
We got 2y squared and -32 they can reduce.
Okay, so it's not the reduce, but they can factor by 2, right? They both have a 2 in them. So I'm going to actually write this over here for the moment. If I take the 2 out, I have the y squared. What if I take a 2 out of 32?
-16.
I have -16. So when I'm looking at this over here, there is a 2, the one that I pulled out. But then the y squared minus 16 is a difference of squares,
Oh, yeah.
right? So y squared gives me a y and a y. What do I do with my signs for difference of squares?
One negative, one positive.
One negative and one positive in whichever order you wish. And then what do I do with the 16?
It's accurate.
Yeah. It's 4 and 4. And I know that 16 has other values, right? I mean, like I can do 2 and 8 and so forth. But I can't in a difference of squares. It has to be the square root of the 16 that works, right? It will. And so I don't have choices. I have a 4. Looking at the top and the bottom, what do you notice?
1 minus 4 is the same.
Y minus 4 is the same. Anything else? No. So my solution in factored form would leave y plus 6 on top, but in the denominator, I would leave the 2 out of the y plus 4. Again, not because it's wrong if I multiply it through, but because it's unnecessary to do so. I don't know about you, but I don't want to do more work than I have to, do you? No. Leave it. Just leave it. All right, any questions on that one? Okay, taking a look at 6 and 7, what do you notice that we've expanded this to do now?
Multiply.
Multiplying. We're multiplying fractions, but the reality is multiplying fractions is the same as having a denominator like this all together and these two being in parentheses, right? Like that's what multiplying fractions is. It's that they're already in partially factored form. That's really what multiplying fractions does for us in this form. So if I take a look at each of the parentheses individually now, so let's just look at the first one, the 2x plus 18. 2x plus 18 has something in common. What do they share in common?
2.
A 2. So I'm going to pull a 2 out of that piece of my numerator. And if I pull a 2 out of 2x plus 18, what am I left with?
X plus 9.
X plus 9. And we move to the second piece. 7x plus 56. What do 7x and 56 both divide by? 7. So we're going to pull out a 7. You can put the 7 in parentheses here. You can actually just write it there as well. What you can't do is put a sign in front of it. All right. If it were a -7 you pulled out, it would require you to put it in parentheses. So if you just want to get in the habit of doing so, just put it in parentheses now. So if I pull a 7 out, I'm clearly left with an x. What's 56 divided by 7?
8.
8. Those multiplication facts, right? Okay, same thing on bottom now. The x plus 8 I can't do anything with. It's already as broken down as it gets. What will I do for... That's not what I wanted. For the 8x plus 72.
8.
Yeah, I can pull out an 8. 8x divided by 8 is x. What is 72 divided by 8? 9. Okay, that is completely factored now. Tell me something you notice that we can reduce or cancel out.
X plus 8 and X plus 9.
All right, the x plus 8s, the x plus 9s, and there's one more thing,
The 2 and 8.
the 2 and the 8. This 2 divides by 2, and this 8 divides by 2, leaving you with 4. Careful to capture everything that still remains, because we've got a lot of markings here. There's a 7 on top. There's a 4 on bottom. That's all that remains on this one. This is equivalent to 7 over 4. No variables left on that one. Okay, uncommon, right? That doesn't always happen, but that's what happened here. All right, number 7. Same thing, we're going to be looking at the pieces factored. So we have this going on. like so. All right, the x plus 3 in the first piece is already in factored form. That's fine. But the other piece in the numerator is a trinomial now. It looks like the things we had showing up in the last section, right? The last couple sections. I need to factor that. So again, I'm going to use trial and error, but if you want to use AC, you certainly could. The fact that there's a 1 in front of the x squared makes trial and error not so bad. So I can do x and I can do x. What does the negative 2 at the end tell me?
Oh, different signs.
Different signs. So one positive and one negative. And then I need two numbers that multiply to give me 2. Well, there's not a lot of options there. It's 1 and 2. We just need to make sure we get them in the right places because one of them is a positive and one of them is a negative. So which one should be positive? Should it be, and go right here, should it be the 1 or the 2? It should be the 2. Why should it be the 2 instead of the 1?
1 or 2 plus negative is still 1.
Yeah, I'll draw them on top. This here is a positive 2, and this here is a negative 1, and those would add to give me a positive 1 in the middle. Okay? All right, and then at the bottom, let's start with the first piece. X squared plus 2x plus, minus 3. Trial and error, 2 parentheses, x and x. What are my signs?
Different.
They're different, so a positive and a negative. Whoops, negative. And again, like the 3 at the end, there's not a lot of options. I mean, the only way we can get 3 at the end is multiplying 1 and 3 together, right? I just need to make sure I put them in the right place. So which one here should be positive? Should it be the 1 or the 3?
3.
3, because the 2 in the middle needs to be positive, right? So when I check again, if I've put them in the right place, in the middle I have 3x, on the outside I have negative 1x, that adds to 2x. So we're good. All right, how about my last piece in this in parentheses, the 3x minus 9?
Take the 3 out.
I can take a 3 out,
Minus 3.
and I have x minus 3. Fantastic. Okay, completely factored form. What will reduce?
X minus 1, x plus 3.
Okay, x minus 1s, x plus 3s. Yes, sir.
The x plus 3 on the numerator, why is it x plus 3?
It's supposed to be negative.
Ah, it was a minus because I wrote it wrong. That's why. Okay, let's fix it. That was supposed to be a negative, so my cancellation will still work, but not with the right term, the same term, right? There's an x minus 3 on top and an x minus 3 on bottom. Sorry, thank you for catching that, Nolan. The real answer of why it's wrong is because I zoom in and zoom out constantly, and I lose signs all the time. So keep me on track. Okay, the only thing that's left on top now is x plus 2. What's on bottom?
3 and x plus 3.
Yeah, 3 and x plus 3. And if you put x plus 3 and then 3, that's fine too. It doesn't matter. Good? Okay, let's try another one. I think we've just a couple more, right?
Yeah, this is the last two.
All right, last two. And it's division. Okay, what do we do with division?
Flip.
We flip. Which one do we flip, Simon?
Change second fraction.
We flip the second fraction, right? Okay, so anytime we have division, it's going to become multiplication. We keep the first one. We change the middle term, the middle piece, which is the division, to multiplication, and we flip the last one. So sometimes I had a student that I was watching, and maybe you guys heard it this way too. It's the first time I'd ever heard it, and she called it KFC. Keep, flip, change. That's what she said. Keep, flip, change. You keep the first one, you flip the second one, and you change the sign. It's KFC, which used to stand for Kentucky Fried Chicken, but fried is a taboo word now, so you can't say that. Did you know that?
What?
It's Kentucky Fresh Chicken. They changed it.
That's
What?
dumb.
Not joking.
Finger looking
All right,
good.
fun times. Finger looking good, but that's not what the F stands for either. Sorry. All right, anyway, so we are going to flip the second piece, and we're going to change the division to multiplication. So the first piece is still 8 over, I'm just going to do those pieces right now, and then we'll go back to what we were doing before, 3x minus 9. And then I'm going to change it to multiplication, and I'm going to flip the fraction on top to say now 9x minus 27, and on the bottom to say 5. Okay, is that all right? That's what we did back when we did fractions in the first unit. We've done that process before. Then the reducing is like what we've just been doing in the previous few problems. So the numerator is just got the 8 in it. Right, we're going to sort of merge these together like this. How about the 9x minus 27?
Take the 9 out.
Okay, so take the 9 out, and I am going to put my 8 and my 9 in parentheses to remind myself all these pieces are going to be multiplied. If I take the 9 out of 9x minus 27, what am I left with?
X minus 3.
X minus 3. Perfect. Okay, how about the denominator, 3x minus 9?
Take 3 out.
Take a 3 out. And I'm left with?
X minus 3.
Okay. And then I have a 5. So, what can I reduce?
X minus 3.
X minus 3. Anything else?
9.
3 and the 9. Good. So the 3 divides by 3 to give me 1. The 9 divides by 3 to give me 3. So as I'm capturing all the pieces that are still here, there's an 8 and a 3 on top, which gives me 24. And all I have on bottom is a 5. So I just have, again, numbers that this one ends up boiling down to. 24 over 5. All right, looking at the last one, what's the first thing we're going to do?
Change flip.
Keep, change, flip. All right, so we're going to keep the first one just like it is. So it's x squared minus 3x plus 2 over x squared plus 5x plus 6. It's going to become multiplication, so I'm just going to write them all together, but I need to flip the second fraction. So my 3x plus 6 comes to the top, and my x minus 2 comes to the bottom. Okay, so always flipping first, making it multiplication. And then we're going to do our factoring. So how do I factor? That blue's not a good color any longer. Let's use yellow. How do I factor x squared minus 3x plus 2?
What?
What? Where was I? How do I factor x squared minus 3x plus 2? I put my x's in.
One's to be positive, one's to be negative.
Are they?
No.
No.
Maybe.
This is a leading question, right? Yeah.
They're both negative.
They're both negative. Okay, so why are they both negative instead of being one of each like we've seen mostly?
The positive means same signs, and the negative means they're both negative.
Okay, so the sign at the end being positive tells us the signs have to match. The sign in the middle being negative tells us they both have to be negative. That's actually the preferable way to do it, because that means there's no way that I've multiplied and get the wrong signs to go on when the signs match. And I don't have any options. What are the two numbers that give me 2? 2 and 1, right? That's it. I've got a 2 and a 1. And if you want to check to be sure, definitely do so. In the middle, I get negative 1x, and the outside, I get negative 2x. That's negative 3x. Okay, how about the 3x plus 6?
Take 3 out.
Take 3 out,
X plus 2.
and I have x plus 2. Lovely. All right, the denominator, I have another trinomial down here.
Okay, have to match.
So, well, we expect this, the signs have to match. Is that what you mean?
Yep.
Yes. So they have to match, and they have to match and be what?
5x, which is 3 and 2.
What do the signs have to be first?
Oh, well,
Positive. Okay, they have to match because the ending value, that is the 6 here, is positive. They're going to be positive because the middle is positive. So positive and positive. I need two numbers that multiply to 6 and add to 5.
2 and 3.
2 and 3. 2 times 3 is 6. 2 plus 3 is 5. And then the last term, x minus 2, does not factor. What's going to reduce?
X minus 2 and x plus 2.
X minus 2's, x plus 2's. Anything else? No. So on this one, my numerator actually still has a 3 in it. I usually write the numbers in front. You don't have to. And it has an x minus 1. And the denominator is x plus 3. I don't need the parentheses in the denominator, so I tend to leave them off when I don't absolutely have to have them, but if you put them on, it wouldn't be wrong. It'd be okay. Any questions on that? All righty.